the first person we're going to bring live is Peter Skanes, who has a question for you, David. Peter, are you there?
Yep, hopefully you can hear me okay.
You can.
Good. Yeah, thank you. First of all, thanks to everyone for the presentations. Very interesting, very informative. So the question for Dave, really, because it was focused on Ford, is how is the ViVID project being perceived within Ford outside of the UK? And how well would you say Ford UK is positioned sort of within the global organisation regarding digitalisation? So I guess, for example, if you compare Ford UK to other parts of the organisation, I guess such as Ford of Germany, Ford of North America, where the main R&D centres exist, would you say Ford UK is sort of taking a lead? Is everyone on par, or is the UK probably playing a catch-up role, or can you just not say?
Yeah, hi Peter, and hopefully everyone can hear me. Yeah, really good question. No, we're not playing catch-up. We're an integral part of the global project, if you want, in terms of how do we accelerate the integration of virtual engineering into Ford. So I have multiple, you're right, the lead for that, I mentioned it in my presentation, the lead is in the States. So there's a global virtual engineering MBSE team based in the US, but both Ford UK and Ford Germany are part of that team. And that team looked at projects like ViVID, and there's some other pilots, if you want, and other projects around the globe, but ViVID is probably one of the biggest ones that global team looked to, so in terms of to learn what's going well, what's not going well, and then we constantly on a weekly cadence as a minimum, I feed that back to that global team. Does that answer your question, Peter?
Yeah, I think I just wanted to, really interested to see, is Ford UK still at the forefront, of the sort of global R&D effort? But I think you've answered the question.
Yeah, I mean, definitely, and if we think about Dunton is without doubt the engineering center, lead engineering center for transit, and hopefully, as I tried to get across in the presentation, the synergies with transit and virtual engineering are huge, and so the two match very well.
Brilliant. Peter, thanks for your question and obviously your answer, David. Right, so let's move on to the next question. Again, we're going to be brave and try and go live. Robert Palmer, are you there to ask your question? And if you'd like to make it clear who you'd like to direct it first to, that would be great.
Well, I think it's for all the panellists, and I'd first of all just like to endorse Peter Skane's thanks to the panellists and your efforts of putting this together, Bradley, on behalf of all the delegates. And I think these whole series of APC seminars are brilliant. It kind of reminds me that we're back at college, but I mean that in a very good way. And like you, I wish I had these set of tools when I was a test development engineer way back when at Vauxhall. So my question, is ViVID applicable and affordable for niche vehicle development? Because specialist low volume production is a particular UK strength.
That's a good question. Maybe the best place to start that is probably with you, John, at McLaren, as you to some degree are niche volume. So do you want to have a crack at answering that one?
Yeah, I suppose so. We do work with niche developers, and I think yeah, as you say, we are ourselves. What I would say about the simulator is that it's an expensive tool, but you don't have to buy one. So as part of ViVID, Ford have not purchased the McLaren simulator. They are coming and using our simulator, not quite on an ad hoc basis. We have a kind of a development plan, but it can be used as little or as often as you would like. And if you are already working with simulation and you already have vehicle models, which is for a niche manufacturer the cheapest way of developing a vehicle these days, then as you would have seen, it already fits into the existing architecture that we've got. So I think it's probably the most cost-effective way, certainly more than producing mule vehicles. So essentially, if I'm understanding you correctly, John, you're saying niche volume and niche players can definitely advance their capability, but it's probably through accessing that capability within the supply chains. Absolutely.
rather than maybe investing in that technology themselves.
Exactly.
Yeah, no, and I think that is a common thread through all of this. And that I talked about it briefly earlier around co-creative. That is where we have a real opportunity within the UK to create that national capability across both our OEMs and our supply chains, which again is hopefully one of the reasons why IPG themselves invested heavily to build their presence in the UK. Rob, does that answer your question? Okay, we'll assume that. But Rob, thanks very much.
You. I was just sorry, I was still muted. John, thank you very much indeed. Expect a call, and thanks to the rest of the team. A lot of the niche vehicle network players don't have the same deep pockets of Ford, and I think you've kind of responded that we don't have to make the capital investments, but we can still engage with the processes, and it's very applicable. So thanks again, team.
Brilliant. Thanks very much indeed for your question, Rob. So next question, they're not able to come live, but it's a question I think for you, Elliot, if you may. It's a question from Peter Deakin, and I'll let you start there. So where do you see IPG and ViVID sitting with regards to unit hardware in the loop and systems hardware in the loop?
Good question. So I think it goes back to what is the problem you're trying to solve. If I'm interested in an ABS ECU, and I'm only interested in what that ECU is doing, and I just assume that the inputs to it are always accurate, then the unit hill is perfectly acceptable, and that's where I would start. Whereas if I'm interested in a broader infrastructure, then I would expand to only include the things I want to know about in that broader infrastructure. If you talk about a system hill as a full vehicle hill, I think then you get to a really complex type of scenario where you're probably going to be at the same point where you could build a prototype as you could with getting all those ECUs together. So I think it very much depends on what is the problem you're trying to solve, and how do you build up that level of capability. But I think if you know what the answer or what the problem is you're looking at, then you can build an answer that covers either unit or system or full vehicle hill. I think it's very much about the approach.
Brilliant, thank you. George, I know this is something that obviously Loughborough are close to as well. Do you want to add anything to that response from a Loughborough perspective?
Let me unmute. No, I think I totally agree with Elliot in terms of the scalability of the approaches, depending on what you might be trying to do. I think everything can be covered, and this goes a little bit back to our vision that I mentioned in the very end of the presentation of being able to move throughout the development V that is quite obsolete, and the point of moving throughout is exactly that it is obsolete, and you want to be able to very quickly switch between full setups, including subsystems and components and software elements. So yeah.
Brilliant. Thank you very much, George. So I think we're going to push our luck and just do one more question, if you gentlemen are okay with that. With the very last question as well. And again, we're going to go and try and go live to Richard Amunugama. And my apologies if I pronounce your name badly. Richard, are you there?
Yes, I am. Good effort. Thank you, gentlemen. Interesting presentation. So my question is, so simulation requires a lot of testing for validation in the background, so that kind of needs to be done. So large companies can do that. They have that capacity. They also have years of historic data. But a new company doesn't. So isn't there a danger of simulation being focused around large companies and the way the geometries and the technologies they use, and not being able to add value to new techniques or methods simply because there's no validation of it? So you end up having to, as a small company, spend a lot in getting that data into simulation so you can then use it, and it becomes an optimizer rather than a new development tool.
Okay, who would you like to have a crack at that first? Any preference, or shall I?
No, I think it's fairly open, that one.
John, go on.
Well, I was actually going to suggest Elliot.
Okay.
I'm sorry, Elliot, but he's got probably more automotive industry experience than me, and he's selling simulations. So
yeah, it's a good question, Elliot.
Let me take a punt. So I'm actually going to use a point of John's presentation about all models being wrong and lies. I think there's an awful lot of data out there, huge amounts of data that is entirely irrelevant, or it was not categorized so it couldn't be found, or it was only including some camera inputs rather than LiDAR inputs, or whatever it might be. So I think the existence of huge amounts of data isn't necessarily the kind of silver bullet that the big OEMs are looking for, because it might be the wrong data. So really it goes back to what I keep harping on about, which is what's the data you need that helps you correlate your model or your simulation and build a background. And I think there's input data and there's results data as an output, and there's that input data might be the data you require to build your models. It might also be the data you require to build a scenario, an ADAS scenario, of a lot of back and forth of traffic or of incidents or what you want to avoid happening in the future. So that's where kind of the existence of lots of data might be extremely useful. But there are companies out there, some Innovate UK projects, in fact, that are creating better and easier ways of accessing that type of data. So it depends what data you really mean, Richard.
Do you want to add any context to the data?
No, I think I'm trying to keep it quite general, but I think what I'm trying to express is that if you are doing something genuinely new, it's very hard to use simulation in an area where there is no pre-existing data or ability to put it into simulation. I mean, it just doesn't exist. So you end up in a bit of a paradox. It may be something what Georgios had with being able to plug a physical component into other simulation, which maybe allows that, and that aspect looked like it might be the enabler, which gives you that possibility, maybe, of that's what you were going to say anyway.
Can I? Yes. I think we shouldn't be viewing simulation and validation as two distinct stages. I think it's all down to strategy. And of course, if you are starting a very big new project from scratch, you'll have to validate at some stages. But this is a gradual process, and this validation can be built in the very early stages. And then as you develop and you become more mature in simulation, these validations are less and less frequent. And a good example of maturity is finite element analysis has been around forever. And if you design a component, a simple component, and you test the strength using finite element analysis with simple materials, you don't need to go and build the component and bend it to see how strong it's going to be. So this is a good example of mature technology that is already in most companies, in most industries. But I think now we are going through a phase that other technologies, much more recent and advanced, are maturing slowly. And there will be validation. But the other point is, very often in industry, there's this notion that you have to validate down to, I don't know, 5% or 2% in order to be able to sign off. The other comment to be made is that this validation can be gradual, and also the benefits from simulation can be gradual. So even if you, without any validation, you start with a simulation project that offers you an indication or a 10% error margin or a 20%, it's already a very good first attempt. And then you can build, as I said, in your strategy, you can build in very critical validation points and proceed. And as you progress, you'll find that these validation requirements will be fewer and fewer in the future.
Brilliant. George, Richard, are you okay with that as an answer? I think it was a good answer.
No, that was good. And I agree that you don't need a fully validated model to use simulation. I think you just need to be aware of the limits.
Yeah, and bear in mind what Elliot said as part of his presentation: be prepared to fail, but fail fast.
Yeah, fast fail is great. Yeah.
Richard, thank you very much indeed for participating and your excellent question.